అనొచ్చు లేదా we will start exercise అని కూడా అనొచ్చు. Shall I
Yeah.
అనొచ్చు లేదా we will
Now
start
the screen is visible, ma'am.
Okay.
Shall I start?
So these are the various studies they have made on their model learning rather than completing the model. So earlier started with the conventional model VGG-net as well as AlexNet. So what is this with augmentation or without augmentation is, if you don't have enough data, you can fabricate the data, or you can generate the data, or you can create the new data. Anyway, any word you can use. You are fabricating new data, or creating new data, or generating new data with the help of the augmentation technique. And with that, what was accuracy they have got, what was the sensitivity part they got, precision, accuracy, specificity, what they got, everything they have plotted over here with the conventional VGG-net and the conventional AlexNet. And for the sake of research, they have added their own additional layer. You can see in the previous diagram what was their additional layer at the end, and based on that layer they have come out with the good accuracy of results compared with the existing VGG-net and AlexNet. So they have tuned the existing architecture with additional layer, and they call it as their own layer. And they found that at this particular combination, there are two models they have suggested, not by one model. They have suggested with the two models. The second model has a very good amount of precision in terms of identifying the condition of the patient. The accuracy also very good, 99.22. So for the real world devices or a solution, as it is a very critical healthcare solutions, we cannot compromise on the accuracy. So for that reason only they have expanded their research, and they come out with this much result. And I found one more interesting application on this smart healthcare using deep learning called the cognitive smart IoT framework. So here the idea was to analyze the EEG signal of a patient to identify the pathological condition of the patient from the EEG data. And they have done two phases of work, one on training part and another is real time testing part. And on the training part, they have used the TUH data set with which has 3000 abnormal and 10,000 normal EEG signal characteristics for learning the pathology. And for the real time environment, they have suggested to formulate a smart IoT framework which has this kind of an architectural structure. These are the vital parameters they have considered for their research: body temperature, heartbeat rate, blood pressure, as well as the voice, and then facial expression, and then body movement, as well as the EEG. So these are the various physiological signal they have considered, and these are the domain they have used for forwarding the signal to the cloud environment. And at the cloud environment, they had built up their own cognitive engine with the help of a deep learning classifier, server, which is going to identify